Good evening, my YouTube viewers. It is Crystal here, and I just wanted to make another code review for you, and we're going to be going over some more Sklearn clustering. And on this video, we're going to be going over the breast cancer dataset. The breast cancer dataset has only two classes, a 0 or a 1, so it should be a little bit easier for the clusters algorithm to pick out the clusters. But having said that, the breast cancer data set has 30 columns of data, not including the target. So that's also going to pose some problems for the clustering. But what I did was I inserted code to remove columns of data that had a high correlation. So that removed about 10 columns of data. So that reduced the columns of data from 30 rows of data to 20 rows of data, to try to improve the accuracy, because the model would not have as much data to cycle through to try to cluster. So that's what I've done. So we have written this program in Google Colab, and Google Colab is a program that I use a lot for my data science work. The only thing that I don't like about Google Colab is the fact that it doesn't have a very good undo function. But aside from the fact it doesn't have a very good undo function, it's a pretty good program to use, and I like it better than the other program that I use, it being Replit. So after we've created our program, what we're going to do is we're going to import our libraries. So we're going to import NumPy as MP, and what that does is that performs numerical calculations, and it also creates NumPy arrays. We're going to import Pandas as PD, and what that does is data processing, and it creates data frames. We're going to import Matplotlib at PyPlot as PLT, and what that is a graphics library that plots the data points onto a graph. And then we're going to import Seaborn as SNS, and Seaborn is written on the back of Matplotlib, and it performs statistical calculations while it's plotting the data onto a graph. And we're also going to import Sklearn, which is Python's machine learning library. So we're going to set the figure size to 16,9, and we're going to set the style to gg.plot or ggplot. So after we have imported the libraries, what we're going to do is we're going to read the data set in. So from sklearn.datasets, import load breast cancer. BC equals load breast cancer. Data equals bc.data. Target equals bc.target. And then we're going to take data and we're going to convert it to a data frame. So data equals pd.dataframe data. Data target equals target, and now you've got data, and it's got 31 columns of data, including the target. So most of the values are going to be 0 and some 1s. The shape of the data set is 569 rows of data by 31 columns. The size is 17,639. So you take 569 and you multiply it by 31. That will give you your size. And then the data columns, we've got 31 columns in total. We check for any null values. There's not any null values. And we analyze the target. You notice that you have less zeros than you do 1s. So that means less people have breast cancer than 1s, but you also have a class imbalance. We make a heat map. So you can see we've got a heat map here, and we've got quite a few columns that have a high correlation. So we're going to reduce the columns. We're going to insert code to reduce the columns. So we're going to reduce the columns from 31 to 21. And there's the code that you have to reduce the columns. Now what we're going to do is we're going to create our train and validation sets. The train equals data.sample, brackets, frac equals 0.9, comma, random state equals 42, brackets. And what that does is that shuffles the data set, shuffles data frame, and then train is 90% of that data frame after it's been shuffled. Val equals data.drop, brackets, train.index. And so what the val is going to do, the val is the data frame after it's been shuffled, but you drop all of the rows that are part of train. And then it does that by dropping train.index. And now what we're going to do is we're going to define x train, y train, x val, y val. So x train is all of the columns of train except the last one, and y train is the last column of y train. X val is all of the columns of val except the last one, and y val is the last column of val. And then we check the shape of that to make sure it's all the correct shapes. So now what we're going to do is we're going to check the k-means. So sklearn.cluster import k-means. K-means equals k-means, comma, clusters in underscore clusters equals 2, brackets, dot fit, brackets, x train. So it's going to fit the train set in there, and it's going to make the clusters. So there's your k-means clusters. And then you've got your, after you make your clusters, you've got your predictions. Predictions equals k-means dot labels underscores. So you can see a bunch of ones and zeros in there. So you check the length of k-means dot labels brackets, and it's 512. That means you got 512 rows of data. And you check the type of k-means dot labels and underscore, and it's a NumPy array. And now what we're going to do is we're going to take unique comma counts equals np dot unique brackets k-means dot labels underscore comma return counts equals true. And then you're going to create a dictionary brackets zip brackets unique comma counts. And so you're going to create a dictionary with that information. So you've got 211 zeros and 301 ones. Now we're going to check the accuracy of the predictions, and check it against Y train, and your accuracy is 84.5, which is less. The accuracy is less than it was in the last video I did where I was using the iris dataset, but it's still okay. 84.5 is still okay. And now we plot it onto a graph, and so you can see we've got our two center points. We've got our two clusters of data and our two center points. So now what we're going to do is we're going to go through, find another model that I was working on. I'm just looking for it. The Birch. We're going to use the Birch model because Birch is what we're going to be looking at, because what I wanted to do is I wanted to see if I could find another model that would give me an adequate score. So I found the Birch. So from sklearn.cluster import Birch, BRC equals Birch, brackets, threshold equals 0.1, brackets, n underscore clusters equals 2, brackets, dot fit, brackets, x train. So we're going to fit the data into the algorithm. predictions equals brc.labels underscore, and you can see all of your predictions here, ones and zeros here. So then brc.labels underscore is 512. That means there's 512 rows of data. Type brc.labels underscore is a NumPy array. And then we're going to create a dictionary from the unique and the counts equals np.unique brackets br.labels underscore comma return underscore counts equals true. And then so now you've got your dictionary is brackets zip brackets unique comma counts. So you have 174 zeros and 338 ones. We check our accuracy. Your accuracy is 83.2, which the accuracy is not as good as it was with the k-means, but I just wanted to find a model that we could use instead of k-means just to get a little bit more experience working with clusters. And then so what we do is we plot the clusters onto a map. So you see you've got it's either a 0 and 1, so you've got zeros and ones here. And then we plot the other clusters onto a map as well. So you don't have any clusters, but you can see that you've got a group of zeros and a group of ones. So that's it. That's it for the Birch dataset, the Birch algorithm. And the reason why I'm not doing any more algorithms is because they didn't work out very well, and there's no point trying to experiment on them if they don't work very well. But we did get the Birch algorithm to work not as well as the k-means, but it did work as the k-means. So I'm going to go ahead and close this video because we've covered the Birch algorithm, and I would like to thank all of my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. And thank you very much for watching my video, and I look forward to making more videos for you in the future.